Let's look at number 60 next with completing the square. So let's focus in on 60 here. Now, if you notice what's different about this compared to the ones I've done is we have a coefficient or a number in front of, in this case, k squared, or our quadratic term. You still want to start out by getting rid of your constant term. Okay, so I'm going to have 5k squared plus 10k, and then equals negative 13 when I subtract it on both sides. Now, I can't go into taking half of this if this is not a 1, like it's been on the previous two examples. So what you need to do is, I need to divide by whatever a is, or in front of the quadratic term, whatever that number is. I'm going to divide everything by 5. So now I have k squared plus 2k, okay, and then over here I have negative 13 fifths. And I'm going to leave a little space here because we got to go through the completing the square method. So I'm going to take half of 2, which is 1, and I'm going to square 1, which is 1. So I want to add 1. Oops. I want to add 1 right here, and I need to add 1 over on this side. So this side, just like with the previous ones, I'm going to write this as k, and then whatever we squared to get the number we added here, whatever half of what the b value is, goes in the middle. So this is k plus 1. Over on this side, I have negative 13 fifths plus 1. Now I need a common denominator to add them because I want to combine them, so I'm going to multiply by 5, multiply by 5. So it's negative 13 fifths plus 5 fifths, which is going to be negative 8 fifths. So I get equals negative 8 fifths. Now I'm going to do the square root of each side. So this is going to undo the squaring, so that's k plus 1 equals positive negative, just like on the prior examples. So I want the square root of the top over the square root of the bottom, because I can do the square root in a fraction, you do the square root of the top. Now, if you think back to what we did in the last unit, square root of negative 8. So if I have the square root of negative 8, well, square root of a negative means there's going to be an I on it. So this is going to be an imaginary solution answer. So I take the square root out, that's I square root 8. And if I break 8 down, that's 2 times 4, 2 times 2. I can pull a 2 out, so it's 2i with a 2 left back underneath. So it's 2i square root 2. So I get, here's what I have k plus 1 is equal to positive and negative 2i square root 2 all over that square root 5. Also, if you remember, we can't leave square roots in the denominator. Okay, so all this stuff we did in the last unit with radicals is coming into play here. We're going to multiply top and bottom by square root 5. So k plus 1 equals positive and negative. Okay, it's going to be 2i square root, I multiply my 2 and 5, so square root 10 all over square root 5 times square root 5 is equal to 5. Now I have to get my k alone, so I'm going to subtract 1. We're going to do it in front of the plus minus symbol. So it's k equals negative 1 plus or minus 2i square root 10 all over 5. Now we really want to get these combined and make it look kind of like an answer from the quadratic formula, which is going to be the next section. So this is negative 1 over 1. So what I'm going to do is I'm going to multiply top and bottom here by 5 to get my common denominator. So it'll be k equals negative 5 plus or minus 2i square root 10 all over my common denominator of 5. And you could write them as two separate answers there as well. Negative 5 plus 2i square root 10 over 5, and negative 5 minus 2i square root 10 over 5. And that's probably what it'll look like on the answer key as two separate answers, but you can leave it in this form too.